look at factoring by a method, and this method's called decomposition. So we have our quadratic, and we need to find, instead it's set equal to something, so we're essentially going to find out what x is equal to, and there could be more than one answer. In order to do this, we're going to set the entire equation equal to 0. So we have two terms on the left side, and we have two terms on the right side. So we can either take both these terms, move it to this side, or both these, move it to this side. It doesn't matter what order you do it in. You just kind of make a choice. So what would you like to do? Would you like to move these to the right or these pair to the left?
We'll move them to the right.
To the right? Okay. So when we do that, when you move 2x squared to the other side, it's going to become negative 2x squared. And when you move positive 3 to the other side, it's going to become negative 3. So when you do that, these will now be gone. So it means there's nothing left on this side. So you're left with 0. And 0 represents nothing, is equal to 5x plus 1 minus 2x squared minus 3. All right, now we have like terms. So positive 1 and negative 3 are like terms. And we're also going to put them in the common order. Usually we put the variable to the highest exponent first, then the second highest, and then the constant term last. Okay. So when we do that, we'll have 0 is equal to, this value will go in front, so negative 2x squared plus 5x. And when we combine positive 1 and negative 3, we'll end up with negative 2. Okay? So we have this equation now. So we're going to look at factoring by decomposition. So this is in what's considered like the standard form. And the standard form of an equation or of a quadratic is ax squared plus bx plus the letter c. Okay? And when you do this, when you're doing your factoring, you're looking for two terms that multiply to whatever a times c are. And those same two terms have to add up to whatever the b value is. Okay? So for us, what that means is we're going to look for two terms that multiply to, our a term is negative 2, and our c term is negative 2. So negative 2 times negative 2 is positive 4. So looking for two terms that multiply to 4, and those same two terms have to add up to our b value is 5. Okay. So the easiest way to do this is always go through factors of a value, because there's going to be so many different ways you can add or subtract to get a number, but there's only so many factors. So 2 and 2 is a pair, and they do not add up to 5, so they won't work. But 1 and 4 work. 1 times 4 give us 4, and 1 plus 4 give us 5. So those are going to be two important numbers for us. So 1 times 4 and 1 plus 4. Okay. So the reason they call this decomposition, I'm going to rewrite this equation here again. 0 equals negative 2x squared plus 5x minus 2. The reason they call it decomposition, because what we're doing is we're taking the b term and we're decomposing it. We're splitting it into two different terms. All the other terms stay the same. So we still have a 0 is equal to, we still have negative 2x squared, we still have minus 2. It's just this positive 5, well, we can split it into these two numbers, into plus 1x and plus 4x. And this is called decomposing that 5. Because if we put these two together, 1 and 4, we would end up at 5. So we haven't really changed the equation. We've just split it up to make it a little more useful to us. Okay. Now once you've done that, your first two terms, okay, we're going to look for common factors of the first two terms and common factors of the second two terms. Okay. So we're going to common factor these two. And then we're going to common factor these two. So in the very first two terms, can you think of a common factor, a value that comes out of both of those?
1.
1. Yeah, 1 comes out. And what about a variable?
X.
Yeah, we can take x out of both, or 1x if you want to say. So the number, or sorry, the value we take out goes in front of our new set of brackets. Okay. And then when we divide these values, negative 2x squared divided by x, well, that just gets rid of one of the x's. Okay, and negative 2 divided 1 is still negative 2. So we're left with negative 2x. So that stays in here, negative 2x. And when we divide 1x by x, we're left with just 1. So positive 1. Is that common factoring familiar? Okay. So then we're going to do that again in the second set of brackets. So what would be a common value we can pull out of here?
2.
2. We can take 2 out of both of these. So because we're taking positive 2 out, we say plus 2 here. And then we have bracket 2x, and then well, sorry, 4x divided 2 is 2x, and negative 2 divided 2 is negative 1. Okay, so what's important here is we need both of these brackets in order to do this style of factoring to be the same. Are they the same right now?
No.
No. Okay. But is there a way we can make them the same?
Multiply the entire equation by positive 1?
Yeah, oh, okay, or a negative 1. The idea is that these are kind of opposite symbols right now, right? Mm-hmm. Which means when I common factored, I could have actually common factored out negative x. And if I had common factored out negative x, okay, so think of it like we divided everything by negative x. Okay, so negative x would be out here. Well, this would now become positive, and this other value would now become negative, okay? And the reason being is a negative divided negative is a positive. Positive divided negative is a negative. And when we do that, now we have two sets of brackets that are the same. Okay, so keep that in mind. If you ever end up with the same values but the operations in front are different, you can just factor out in negative values. So we factored out negative x instead. So now that these two brackets are the same, okay, this is good. The idea is that we're technically common factoring these two brackets out. Think of it like I'm dividing this term by 2x minus 1 and this term by 2x minus 1. You don't always have to show all these steps, but this is what's really happening. So we have 0 is equal to our common factor, which is 2x minus 1. And then whatever's left over would go into the other bracket. And whatever is left over are the terms in front. Negative x plus 2. So we have negative x plus 2 in the other bracket. Now this one can seem confusing, so I'm going to kind of write it on the side. Think of it like it was like this. Negative x, and we're going to say let y equal 2x minus 1. Okay? So instead of writing this bracket in, I'm going to say negative x times y. That y replaces what we highlighted. Okay? And then over here it'd say plus 2 times y. Okay? If we go to common factor, well, it's simpler to see or easier to see than in this example. That y comes out. We'd have y times negative x plus 2. Okay? When we finally common factor that. So that makes sense. This negative x plus 2, that's what this bracket is. And y, well, there isn't really a y. Y is this value, and that's what this is instead. Okay, so if you ever get confused at this part, you can kind of sub something else in. But just realize, if you have these two brackets the same, you turn them into one, and then whatever's left over goes into the other bracket. Okay, we're not done. We need to find out what x is equal to. So because we have two sets of brackets multiplied by each other, and they equal 0, that means one of these must equal 0. Okay, we just don't know which one. So we're going to split them into two. We're going to set both of these equations equal to 0. So we have 2x minus 1 equals 0, and negative x plus 2 equals 0. It's the only way to multiply and get a 0. You have to have a 0. Okay, so we solve for x. When I move negative 1 to the other side, it will become positive 1. So we now have 2x equals positive 1. And in order to get x by itself, when I move 2 over, we divide. So we're left with x is equal to 1/2 or 0.5. And on this side, when we move 2 to the other side, it becomes negative 2. So we're left with negative x equals negative 2. And this negative x, think of it almost like it's negative 1. And to get x by itself, we always want x to be positive. We move it over by dividing by our negative 1. So x is equal to, oops, negative 2 divided negative 1 is positive 1. So these are our final answers. These are the two possibilities for our x. Okay? That was a very detailed and difficult question for us to do.